So let us see how we are going to show that, or how we are going to prove that this a power p such that p is a regular or not. So before going to look see that, first of all, let us write the language, what this language consists of. P is a prime number, so you will be having two a's, a square, a cube. 3 is a prime number, so a cube. 5 is a prime number, so 5, a power 5. 7 is a prime number, okay, 7 is, and so on. So 7, 11, 13, okay, then 17, 19. So you will be getting prime number of a's over here. Okay, now the next thing what we have to do is, we need to, from this language, just remember the theorem. Once you have some language called L, from this language L, now you need to select some string called W. You need to select some string called W. Now let us take this string. Now I am taking this string called W. So name it W, and this is the string. This is the string. And here, what is the n value? What is the n value here? Where n is equal to 1, 2, 3, 4, 5, 6, 7. Because we have taken n as a 7. N as a 7. Now, once you have taken n as 7, now what we have to do now? The first condition, now we need to check. What is the first condition? So before going to check the first condition, first we need to check that whether we have taken a string, whether we have taken a string W which is greater than or equal to n or not. So first do that check. So string W is greater than or equal to n or not. That is what we have to check. What is the string length of the string here? 7. 7 is greater than or equal to 7, because our n value is also 7. Means now the condition is true. Means now we have taken the proper string. Now for this string W, now we need to divide this string 1, 2, 3, 4, 5, 6, 7. Now we need to divide this string W into 3 parts. What are those 3 parts? X portion, Y portion, and Z portion. So totally we need to divide this into 3 portions, X, Y, and Z. So how we have to divide? Subject to 3 conditions. What are those 3 conditions? The first condition is, let me copy this one itself. The first condition is the length of the pumping part should not be equivalent to 0. The length of the pumping part should not be equivalent to 0. Okay, so let us check that one. So select some value. uh, okay, so select some y value, so that this y should not be equivalent to 0. Now what I am doing, just observe. Now what I am doing here, I am going to take some y value, this one. I am going to take some y value. This is the y value which I am taking. I am going to highlight with the yellow color. This is my y value. So what is my y value now? AE. This is my AE. Y value is AE. Now, for your reference, I am going to write the colors also. Yellow color, whatever the yellow background which I have taken, that is my y value. Now let us check y is greater than or equal to 0 or not. Now what is y we have taken? AA. So this AA is greater than 0, 2 is greater than 0. Now with this, the first condition is successful. Then what is the second one? If this is y in the sense, then what about x? X will be 4s. X will be 4s. Now I am going to call it like a red color. So let us take x like 4s, which is available in red color, which is there in red color. Okay. Then third one, z. Now I am going to take a green color. Z is a small a, which is available in green color. So this is my division, what I have done. Now, if you want to do, you can do in any other ways also. There are multiple ways where you can divide your string. But I have done the division like this. Now, you need to make sure that the length of x and y should not be equal, should be less than or equal to n. What is x over here? X is 4s. X is 4s. So 4s and y is 2s. Y is 2s. So totally how many a's we got? We got now 6 a's. What is the value of n? The value of n is 7. So 6 is less than or equal to 7. 6 is less than or equal to 7 means this condition is also true, means now we have properly divided our given string w into three parts like x part, y part and as well as a z part. Okay, now let us take the third condition. This is very important condition. What is that? We need to take this x power x y power k into z for all k greater than or equal to 0. This is what we have to check. What is our x value? Our x value is 4s. So our x value is 4s. Then what is y value? Y is AA. Now I am doing AA power 0. Y AA power 0. What is our z value? Z value is small a. Z value is small a. Why I am taking power 0? The reason for taking power 0 is the value of k should be greater than or equal to 0. Now, when you do the result over here, the result will be 4a's concatenated with epsilon. Then we got small a. So, what is the answer now? We got totally we got 1, 2, 3, 4, 5. In the sense, now please check, please everybody pay attention over here. Now we got totally 5 A's. How many A's we got? 5 A's. Now when we got 5 A's, whether this A power 5 is belonging to this language or not, you can see whether we have 5 A's or not. Yes. So just observe. So A power 5, this belongs to capital L. This belongs to capital L. Now, once we found that when we pumped this y portion for 0 times, now we got this resulting string. And this resulting string is available in the given language L. Now, straight away, as it is available in this given language, so straight away, we should not decide, please remember, straight away, we should not decide that this language is regular. Now, what we have to do now? So, this is for case k is equal to 0. K is equal to 0. Now, we need to check the same for case k is equal to 1. Now, why I am asking you to check for k is equal to 1, k is equal to 2 also in the sense, because here this condition, what is this condition? This condition has to be true for all, means for all k values, it has to become true. Okay, now it became true for k is equal to 0. Now let us check for k is equal to 1. K is equal to 1. Now this value, let us take this value is 1. So this value is 1, that is this one. Okay, this time it is not epsilon, it will be a. It will be a. Now how many a's are there? These are 4, then 5, 6 and 7. So 7 a's are there, very good. So this is also okay, a power 7, that's also fine. That is also fine. Okay, next, go for next value. K is equal to 2. Let us take k is equal to 2. Let's see what is going to happen. What is going to happen? Let us see a power 2, a square, and here you will get a. Then how many number of a's are there? 4 a's, 4 a's and 1 a. Totally how many number of a's are there? Totally 9 a's will be there. So 1, 2, 3, 4, 5, 6, 7 and then a. Totally 9 a's are there. Now please check, we have this one, 5 a's are going to belong to L. Why? Because we have taken the language such that my language should consist of a prime number of A's. And the next one, what we have taken, so 7 A's are also available. But what about this one? 9 A's. Now tell me whether 9 is a prime number or an odd number. 9 is a prime number or odd number. 9 is a odd number. It is not a prime number. Means now when I look into this language, the next number of A's will be after 7, the next number of A's will be 11, but not 9. Means now we are able to find that. Please understand over here. Now we are able to came to know that when I pump this portion, this y portion, pumping portion for twice, how many number of times? 2 times. So I came to know that I am able to generate a string. Which is not belonging to the given language. Now that is the reason why now we can say that so this language is not a regular language. So let me write over here when y is pumped for two times. When y is pumped for 2 times, it generated a string consisting of odd number of A's instead of what? Instead of prime number of A's. Or I can write instead of the number of A's of prime number. So hence we are able to generate a string which is not belonging to the given language. Hence the generated string is not belongs to, or string does not belongs to the given language. It is not going to belongs to the given language. Okay, so that is the reason we can say that. So this language, this language is not regular language. Okay, so like this, what we have to do now, we need to prove that whether the given language is regular or not. You can see here in our earlier case, straight away with the k is equal to 0 itself, so it has been proved whether the language is regular or not. But it is possible that, so depending on the combinations, so how you are going to divide your x value, or how you are going to take y portion and z portion, depending on these x and y and z portions, so sometimes it is possible that you will able to prove the language is not regular with k is equal to 0, and sometimes it is possible that you can prove with k is equal to 1 and more than 1 also. But in this scenario, what we have done, we are able to prove that our language is not regular when the k value is equal to 2. So when the k value is equal to 2, now we are able to prove that our given language is not regular. Okay, so like this, what you have to do, you need to take the string, language. From the language, you need to take some string. From that string, what you have to do, you need to divide it into 3 portions. After dividing it into 3 portions, so how you have to divide? You need to divide the string into 3 portions. So subject to these 2 constraints. If these 2 constraints are satisfied, then you can look into the third condition. Okay, now that's the reason why we said like this pumping lemma theorem is a contradiction. Contradiction in the sense, we are using this pumping lemma not to prove the language is regular, but to prove that the language is not regular. Okay, so this is how we are going to make use of the pumping lemma theorem. Okay, now let us take one more example. like WW. Let us take one more example. Uh, Here, this for this exercise also we can apply our common sense and we can say, like, we can decide whether the given language is regular or not. So we need to prove that WW, where WW is nothing but what? Where W is nothing but what? W is a set of strings of zeros and ones. And please observe here we have plus. If you have plus in the sense, now my language is not consisting of a epsilon. My language is not consisting of a epsilon. Okay. So we need to prove that the language is regular or not. Check. So here we need to check, or straight away I'm going to write, already problem statement was there in the above. So we need to prove whether this language is regular or not. Okay, so how do you prove that? So first we need to take the language. Okay, so what is the language here? The language is W followed by W. In the sense, if you take W as a 0, then that 0 is immediately followed by one more 0. If you take W as 1, it will be followed by 1. Why? Because W followed by W. What is this W is? So just now I told you it is 0 plus 1 whole power plus. Plus in the sense, now my language is not going to consist of epsilon. My language will be consisting of 0, 1, 0, 1, 0, 0, 1, 0, 1, 1. Like that my language will be. Okay. Now please observe. Now if I take W as 0, W as 0, but we are talking about this language. We are talking about this language. So it will be 0, 0. What is this first 0 is? The first 0 belongs to first W. First 0 belongs to first W. And the second 0 belongs to the second W. Okay. Then 0, 0, 1, 1. 0, 0, 1, 1. So what this second one represents? The first one refers to W and the second one refers to second W. So 0, 0, 1, 1. Then the next one will be 0, 0, 0, 0. Next, this is the W, 0, 1. Next 1, 0, 1, 1. These are all W's. These are all W's. But we need to write W, W. Okay. So 0, 0, it will be 0, 0. This will be 0, 1. It will be 1, 0. And it will be 1, 1. Okay. In the same manner, if you take 000 as W, then WW will be 000, 000. And you will get and so on. And so on. Now, if you observe, there is a complication present in this language. What is that complication is? So now you need to remember what is the W. You need to remember what is the W, and we need to compare. See, we need to compare whatever the W you have identified with the next W. With the next W. And one more thing, one more difficulty here lies with this language is, so our automata does not know what exactly the W might be. Okay, so that is the reason why, we say that, so this language is also, this language, even though it is a infinite language, even though it is a infinite language, but still we can say that this language is not regular. It is not regular. Okay, so we are going to see if this language is not recognized by the finite automata, but this can be recognized by one more finite automata, which is the push down automata. So we are going to construct the automata for this also when we are discussing about the push down automata in next subsequent sessions. Okay, this is the one more thing, and we have one more example, just same like this one also, just same like this itself. So W power R, we have W power R reverse. If W is this one, if W is 0, its W power R is also 0. W is 0, W power R is also 0. For 0, 0, reverse will be 0, 0 only. But for 0, 1, for 0, 1, the reverse will be 1, 0. For 1, 0, the reverse will be 0, 1. For 4 months, we don't have any problem. For zeros also, we don't have any problem. And now if you look into this and straight away I can tell you like whether this language is regular or not. So straight away, this language is not a regular language. So why this is not a regular language? The reason for that is we know, even though if you know W, what is W, but we don't know exactly whether we are going to read the reverse of W or not. In the sense, see, straight away we are not able to know what is W and what is the reverse of W also. Okay, now that is the reason why we can say that even though this language is a infinite language, but still it is not a regular language. See, for these two examples, for these two languages, we are going to see so how we are going to construct the push down automata. See, I'm not saying that these are not at all languages. These are languages only, but these are not specifically regular languages. But these two are the best examples for context-free languages. So these are the languages so which are recognized by the push down automata, our next automata. Okay, so I will discuss about the hierarchy of languages and the automatas, everything, what are the grammars that each and every automata is going to accept. So everything we'll discuss it in the next class. Okay, so this is how we are going to prove that. So this language is also not the regular language. Now let us take one language which is going to be a regular language, and let's see how it is going to happen. Uh, okay, let's check this one. Let us take this language. We need to prove that we already know that this language is a regular language. Let us check this one. Or no problem. So we already know that for all these languages we already proved that they are all regular. So it doesn't make sense that again improving them like whether they are regular or not. Okay, so with this we have finished the pumping lemma part also, and we have finished our second unit also. And in our next class, we are going to start the discussion of our third unit, and where we are going to cover some more topics related to grammars itself. Okay, so that's it for from my side for today's class. So thank you very much for joining the today's session.